Welcome, everyone. Thanks for joining our 15th user group meeting. Well, yeah, it's been a while. Today we have a few topics to cover. We'll start with the Scaffold Tree. I will present it, and then Leonid will describe our recent improvements in cheminformatics and our docking visualization feature. Then Alexandra will describe our recent work on ADME-Tox calculations. Alexander will showcase the new visualization and the new capabilities for hierarchical clustering. And then we will conclude with some updates general in the user interface and some interesting features that are related to forms in the spreadsheet. And of course, we will have our time for questions and answers. And by the way, please keep the questions going. Let's keep it as interactive as possible. All right, so with that, let's talk about Scaffold Tree. So Scaffold Tree is a way to organize and navigate in a collection of chemical structures. You can see it on the left. I've already created a tree, but to create a new one, you can go to Chem, Analyze Structure, and Scaffold Tree. I'll close this one since we already have it. And the way it works is that a hierarchy of chemical structures is created. It can be done either automatically, which was the case in this tree, or you can sketch it manually. And the way it's structured is that each successive structure is a superstructure of the previous one, meaning the previous structure is a substructure of the next one. It allows for very intuitive organization of your structures and navigation. So, for instance, we can see that we have multiple roots in this tree. Clicking on a structure, we'll see all the molecules that match it. We can also open the hierarchy and drill down. The visualization is integrated with the rest of these Datagrok visualizations. So, for instance, if we want to add a couple more visualizations, for instance, a histogram. You can see that by clicking on the molecule or even hovering over it, we see the distribution of the corresponding activities, or in this case, it's heavy atom count in the rows. So it's a way to interactively explore your data set as well. The way it's integrated with filters, it's also convenient. When you click on a structure, the data set is filtered, but you can adjust the filter by, for instance, checking multiple substructures, in which case all of them will be visible. You can reset the filter using this button. So this particular tree was generated automatically. we use the open source scaffold graph library, which we have heavily modified internally. It uses RDKit. But quite often you do not need to have this tree generated automatically. Sometimes chemists have their own ideas of what the structures should be in the tree. So we support that mode as well. At any point of time, you can modify the existing tree, or in this case, I can just remove everything and start sketching from scratch by adding a root structure. So let's add something. By the way, as I sketch, we see the corresponding structures that match it. So I've created one root structure. Let's create another one. Now to create a child node, we would hover over a node and choose the plus sign. By default, a sketcher appears with this parent structure, and it's possible to narrow it down even more. I think I did a little bit too much. Yeah. Just like that. In this case, as you can see, an interesting thing happened. So now we got not only the child structure, but a node that represents a folder. So this folder contains orphan molecules. And orphans are defined as molecules that match the parent structure, but do not match any of the siblings. So as you can see, these structures match that particular scaffold, and the rest still match the parent, but do not match the sibling. Of course, if you create your and curate your collections, but by hand, you want to persist them, and we support that as well. At any point of time, you can simply download the tree, it's done, or you can open a previously saved tree. That was a big one. So switching between them is real simple. Regarding the future plans for this feature, we plan to enhance it in multiple ways. First of all, we want to integrate it with molecular filters. They already work just like molecular filters, but we will integrate it nicely into the filter group. It will allow us to, first of all, quickly switch between molecules for filtering options, and of course to have that hierarchy tree. The second way we are planning to enhance it is that we will rewrite the whole implementation using C++, so the whole code will run in the browser. So essentially it will be just generation of the tree will be much faster. So that's going to be an interesting initiative. Any questions about the scaffold tree?
I have a small question. How can it be installed on the customers' installations?
Sorry, Alex, I didn't hear you say it.
How can customers install it on premises installations of Datagrok?
Right, thanks. So at the moment, it's part of our Chem plugin, which is our central Cheminformatics plugin. So normally, yeah, the customers will simply update to the latest version of Chem, and yeah, everything will be there. All right, thank you. If there are no more questions, I'm passing the stage to Leonid, who will go over Cheminformatics updates. I think I need to make you a host, Leonid. You are a host now.
Thank you, Andrew. Am I presenter now?
Yes.
So first of all, I would like to tell about our new feature that is on the one side is a Cheminformatics update for the support of the annotations and file formats, and on the other hand is our first steps to support structure-based drug design. Imagine the situation that you have a data set of the new inhibitors, and you would like to test them in the way to select the most potent and then proceed in your in designing of the new drug. And one of the way to do that is to use docking. And in our example, we will see the inhibitors of HIV protease, an enzyme of the viral enzyme that is one of the main targets of HIV, and the development of the new inhibitors for this molecular target is still actual as HIV evolves rather fast, and the new inhibitors are needed. Having only 2D samples, you are not able to perform this type of analysis, but if you have the 3D structures that were already docked to the protein, like that, oh, sorry, you will see that they have, they don't look they're represented in their 3D structures. So let us first beautify them. And this we can do using the column options, Chem, and regenerate coordinates feature. So as you can see, the structures are now in two-dimensional, looks like two-dimensional pictures, but they still have their 3D coordinates hidden. And to look for the structures in their protein, in the protein active site, we should upload the protein itself. So to do that, we will add NGL viewer. And we'll open the appropriate file with HIV protease. So here it is. As I have mentioned, the three-dimensional coordinates are still here, and we should choose the molecules, those ligands that we want to see in the active site of the protein here. Let's choose just one of them. So here you can see the conformation of this structure in the active site, and you can inspect it with what structural fragments of the enzyme it interacts, and to compare it with the other forms. In this example, we have the reference compound, so we can select it with any form given to compare how the conformation looks like within the active site. And of course, using the standard data group tools, we can just select those that have the highest ranks that were derived from the analysis, and again expect them here, comparing to the reference compound. So that's it for this feature. Before we proceed to the other chem updates, are there any questions? All right then.
Lenny, did you say the compounds were pre-docked? So that's how you know the position in the pocket?
Yes, right. So the docking procedure was already done for them. And here we can observe and proceed with further analysis.
So this is the NGL viewer is just a visualization. That's all it is, right?
Yes, for now it is visualization.
Okay, thank you.
So we have a bunch of small updates for chem. Let us open the examples. And first of all, we started to refining the structure to be more convenient for user. For example, now nearly all the features are stored in chem top menu option. Those are transform for mutate and curate, specializing in structure activity relationship features as activity cliffs, structure alerts, and R groups, calculations, searches, and analyzing structural forms without associated activity. So, and for the convenience of users, the chem column, the column with molecule structures, has now a tooltip with the data set analyzation and now it shows the most different structures, but actually it could be optional to show the most frequent scaffolds in the data set. Another update is associated with sketchers. There were a few requests for this option to scale the height and width of the sketcher for the big molecules that are not easy to sketch in the small sketcher. And with the use of this sketcher, I will show the next feature. It is associated with substructure search. Substructure search is a feature to search substructure, as you might know, but it had some peculiarities. I will show you them now. So, for example, if we sketch the molecule that is a real molecule, like benzene, there is no problem to filter the set by it. Another thing is that when we sketch a molecule that is not real, so in this example, I will make a hexane with one aromatic bond. And as you know, these structures are not present in the real nature, but there are chemical queries that can be associated with the molecules that contain this substructure. And as you can see, there were some hits here that having this ring with the neighbor of the aromatic ring. Both of these examples are simple cases. The complex case is when you make a query with unreal aromatic combined with real aromatics. And for now, this feature, substructure search, can handle such complex cases. The thing is that when you filter just with the aromatic ring, it is used as the mol file with the real aromatics. And when you use the ring with one aromatic bond, you should use smart's query within this algorithm. But smart's is not able to use the real aromatic rings as it uses just single and double bonds exactly. You should exactly specify the type of bond. And here we make a transformation of the query to handle these aromatics as aromatics, not calculized form. And maybe last but not least is our update on similarity search and diversity search. So that is the well-known feature. And basically, if you run this, you will get the well-known similarity search. For now, it is augmented with additional features as we have additional data in the columns and we can color it. For example, in this way, we can add these results to the similarity search analysis by using its options and adding the molecule columns to analyze with it. So here it is. We can move through the data set and see how it is. So these similar compounds have the similar properties, of course. So, oh, sorry. Let's restore it. We can fill the color for the whole background or just color the numbers themselves. So that's it. Your questions are appreciated.
The substructure search feature also works with the Marvin sketcher?
Yes, sure.
Good.
All the sketches now work in identical manner. So yes, it should be supported for Marvin and Catcher and all the other sketchers that are present in Datagrok that are listed here. When you use this menu to select the appropriate sketcher of your interest. So yes, it should do the same things either.
Awesome, thank you.
Thank you.
Great. Thanks, Leonid. Since you are the host now, you should probably pass it to Alexandra. Or maybe it's not needed anymore and Alexandra can just start sharing already.
I will try. 1 second. I can't. I have a message that I'm not allowed.
Okay, we'll figure it out.
Can you do something?
Yes.
Mhm.
Yes, you should have enough privileges now.
Yes, I have. Thank you. Right now, you should see my screen. Yes. Okay. As you know, many experimental methods in drug development are costly and time-consuming. Methods of ligand-based drug design can help to overcome a variety of problems. These methods include the prediction of such properties as absorption, distribution, metabolism, excretion, toxicity, also called ADME-Tox. It makes it possible to filter molecules and select those that satisfy a specific criteria of your research. And today, I'd like to show you how we solve that in Dendrogram using our new plugin ADME-Tox. With this tool, you can, firstly, obtain predictions, both for a single structure and for the column. Secondly, get a well-designed and comfortably organized form for every structure of your dataset. And also get a deeper understanding of what each of values mean with the help of our tooltips and color coding tools. Okay, I will try to show you everything. In order to get predictions for a single structure, you need just to click on it like I've done. Then go to the property panel. Here you can see the ADME-Tox pane. You need just to expand it like that. Here you see a couple of categories for our properties, absorption, distribution, and others. In order to get the results of our prediction, you need just to expand each of the pane just to see the results. I will show you all of the results right now, or a couple of them, for absorption, for distribution, for metabolism, for excretion. Also, if you want to calculate the properties for the whole column, you need just to go to the top menu, select Analyze Structure, and then, one moment, I will try to do this again, and select ADME-Tox Calculations, like that. Right now you can see that a dialog appeared. So here you also can see all the categories. You can choose absorption, I will do it right now, and metabolism, for instance, and calculate it for the whole dataset. Right now, we're going to wait for just a couple of seconds in order to get our results. It will take some time. So, and here it is. The thing I want you to notice is that you can filter molecules with desired properties using our standard tools that Dendrogram provides. I will do it right now just in case for you to show that, of course, you can filter all the structures in the data set with all the properties you've just calculated using our ADME-Tox calculations, like that. Now let's move on to our forms. I've already done it, so here it is, our beautiful and well-structured forms. So here you can see that we have a form which contains all the information, all this predicts for each of the structure. It's structured really great, so you can see the absorption values, distribution, metabolism, toxicity values. In order for you to understand what each of the values means, you can just hover the cell and see what does it mean. So for instance, you can see that one structure is inhibitor and that another is non-inhibitor. That works for all of the structures here. And for your own comfort, we have this even in the form, and color coding helped us with this. So I guess that is all for now. Oh, and there is one more thing. Of course, we have some steps for the future. And in our next steps, we will focus on refining existing models and expanding their applicability in the future. So right now, I guess that is 100% all for now. Thank you for your attention.
Thanks for good presentation.
Thank you. Everything is fine. I just, okay. No more questions. Okay, let's maybe move on.
Yeah, thank you, Alexandra. Yeah, the form is really nice.
The form is cool, and with color coding, it's even better and gives you really a deeper understanding of what we're calculating and what impact is going to have. I believe that in the future, this tool will be even more powerful.
Right, and we can provide all the explanations on the fly. What does each value mean, and also how it was calculated, and so on. And indeed, we have big plans for having our modeling infrastructure in Datagrok, so that you will be able to train your own models in a similar way and then apply it similarly.
Yeah, on your own data, it will be really comfortable for you. Yes.
Yeah, unfortunately, I missed this presentation because I had to attend the previous meeting, which has just ended, you know. So I hope there is a recording of this one.
Yes,
of course it is.
There is a recording. We'll send you a link later today when we put it on YouTube.
I have a question about the form. Does it have to be the columns of the table that are displayed there, or it can be, say, properties that are not visible as a column at the moment?
Of
or
course,
from a
there
different
can
table?
be, and even in the future, they can be in other columns, not from the table. And also in the future, they're going even to be a radar for you to show the most valuable predicts.
Awesome. Thank
All
you.
right, forms are pretty flexible. By default, you would simply drag and drop fields to it, but yeah, they support a lot more. You can put viewers, widgets, and other visual elements, and include things like markup that gets evaluated dynamically. For instance, you can reference, I want to show the average of a certain column. So things like that. And yeah, it's pretty flexible. I will touch on forms a little bit later in my other presentation today. All right, thanks, Alexandra. Our next presenter is Alexander, who is now a host. So Alexander, please take the stage.
Hello. Am I the presenter?
Yep.
Okay. Hi, everyone. My name is Alexander. I'm a scientific application developer at Datagrok, and today I will present you the Dendrogram package. A dendrogram is a diagram representing a tree. This representation is frequently used in different contexts. In computational biology, it shows the clustering of genes or samples, sometimes in the margins of heat maps. In phylogenetics, it displays the evolutionary relationships among various biological taxa. In this case, a dendrogram is also called a phylogenetic tree. In hierarchical clustering, it illustrates the arrangement of the clusters produced by the corresponding analysis. We use the dendrogram package for first dendrogram viewer, and as helper for algorithms on trees, such as hierarchical clustering. Dendrogram package exports file handler, allowing to load and present NUVIC files. Opening file with a NUVIC extension will be transformed into a data frame with nodes per row for leaves and internal nodes too. There are columns, node, parent, distance, usual for table-based definitions of trees. The dendrogram viewer is docked on the right side of the grid. It interacts with data frame on which it is opened in two-way manner. The viewer maintains and displays of covered, current, and selected states of a node, this interaction can be synchronized with the state of corresponding rows of the data frame underlying the viewer-linked nodes to rows. The current node is highlighted with the standard green data group color, and the orange branch is for selected state, and mouse hovering is working as the hovered node is drawing with the main color and the whole branch, while the remaining state is shaded with a lighted color. Following the current data frame row is the built-in data drop function. You can see the grid is according to current row. Properties of the viewer allow customizing the viewer appearance for the line width or node size and color of lines and nodes. On the one, also as a lead grid can be displayed. As we will see later, it can be useful to for displaying trees bound to other regular visual structures like a grid. Dendrogram is highly optimized to render trees with hundreds of thousands of nodes. It draws without any lag or delay. On one hand, it draws only objects within a visible window. On the other hand, it squashes all nodes within 1 pixel on the screen. And next point is about Dendrogram injected into a grid. So we open some common data set and run hierarchical clustering from machine learning menu. Here we can select features to be used for clustering. So here we can specify pairwise distance type and agglomeration method, for example, an average linkage. So hierarchical clustering is running from the server side, and result is displayed in a tree bound to on the left side of the grid. As a result, rows corresponding to tree leaves are rearranged in the grid in order according to calculated tree. Mouse over current and selection interactions are synchronized between the grid and injected tree in both directions. Data grok allows filtering rows, for example, for continuous variables, such as, for example, an age in this data set. And as you can see, filtering rows is synchronized with filtering leaves in the tree bound to the grid. This is a basic Dendrogram functionality that I wanted to present today. Our next steps will be to implement a horizontal Dendrogram injected into a grid for the side of the columns, so we could build up some visualization like heat maps. Thank you for your attention. Any questions or suggestions? Would you please?
Thanks, Alexander. This is fantastic. So you've just shown how to build hierarchical clustering for tabular data. Do we provide any ways to do it automatically for biological or chemical entities, such as sequences? Or
not yet. We have We have an example for our customer, but I can't demonstrate it now. If we calculate distance metrics with any metric like Smith-Waterman for sequences, so we could will be able to build hierarchical clusterization based on this distance metrics.
Yeah,
So
Alexander, this is Rutankar. So thanks for showing this, and I feel that this can be directly applied. I mean, exactly on what Andrew said. Like, if we can take like peptide sequences, which is I'm interested in, and be able to cluster them and just visualize the dendrogram on top of that, that'll be great.
Yes, so in Dendrogram we can calculate a dendrogram on the fly, like hierarchical clustering based on distance metrics, or we can preload preliminary calculated tree as UVic data. Okay, yes.
Yeah, do we have that capability to cluster peptide sequences, or small sequence of either nucleotides or peptides?
Sorry.
I'm not sure if we have the capability to cluster small peptide sequences or.
Oh, there is a single question. Can we calculate some distance between two objects? If we have pairwise distance metrics, so we can build any hierarchical clustering based on this distance metrics.
All right, but we need to provide it out of the box for commonly used entities such as peptides.
Yeah.
Okay. I will include the distance metrics for sequences and our nearest plans.
Yeah, so the user interface should look like you open a file with something. A data group recognizes a column with peptides. You click on a column and an action appears cluster.
Right. Okay, okay, thank you for your suggestion.
Taking into account the specifics. Yeah, we can probably do very similar thing for the molecules, since we already have a number of distance functions defined. I'm not sure how useful that would be. I have not seen it quite often in the industry. Maybe Dima can comment on that. Would that be useful?
I would say it's probably useful, yeah.
Yeah, because it would be almost free for us in terms of implementation. Once we implement that general mechanism, we would simply supply a distant function and done.
Yeah, I mean, if it's not hard to implement, you can just implement it and then ask people how useful they find it. That's the easiest route.
Yeah, well, the devil is always in the details. So here, a big elephant in the room is the performance, because the distance matrix can be huge if you run it on even 10K molecules. So we will be using GPUs for that. So yeah, it's coming. Maybe not the next meeting, but the one after that. We should do that.
What I need to do to move my organizational role.
Okay, thanks, Alexander. So if there are no more questions, I'll jump to our last topic for today.
Okay.
Which is forms in a grid. So Andrei has already asked about forms, and Alexandra showed some of it, and we presented it previously. So I assume most of you have some familiarity with it. But I'll describe the top-level idea of that anyway. In DataGrok, we have tons of different ways to visualize your data, and also a number of ways to provide visual summaries for the whole row right in the spreadsheet. So typically, previously we had that summary columns, which is sometimes referred to as spark lines, which allows you to add a column and then specify which data goes into it. For instance, right now we are looking at a spark line that visualizes all 19 or now 17 numerical columns in this data set, and it gives us a quick overview of what is contained in a row. We also have radars, bar charts, and some other ways to visualize it. So now you can quickly visually identify the profile of the compound in this case, or a row. However, sometimes you need more detailed information for the row, and this is where our new feature comes in. Now you can right-click, do Add Forms, and there are multiple ways to provide the form. Let's design one. We would click on designing the form. By default, we put all of the columns and their values. And this form is designable. So let's say we want to visualize it differently. We want to have a molecule. It should be bigger, more prominent. We want to display some molecular number and some attributes along with it. And we really don't care about the rest of the fields. So this is our tiny form. And that's all it takes. Now we get that information right here. It is synchronized with the rest of the spreadsheet. So I forgot which columns we used, probably this one. So for instance, if we color code it, all of that gets picked up. Or we might want to do it like that. So a really nice way to provide a summary for the row. Any questions about this feature?
Well, it looks useful, but there are two things. First of all, you just said yourself, I forgot which columns used, you know. So it's kind of not obvious which ones are which, you know. Really, if you're looking at that form.
Mm-hmm.
And in the form designer, it's not obvious how to actually design it. So if somebody is using it for the first time or just doesn't use the designer often, it's kind of hard to guess what you're supposed to do when you see that form designer, because there are no hints or anything. So at least some kind of tips should be shown if you want to delete, because I thought I would see, like, if I wanted to delete some columns, I would see kind of delete button or whatever, some kind of control, but you're supposed to actually select and then hit delete, I suppose, right? which is
yes,
not obvious.
the UI is lacking a little bit. This is a work in progress, but yeah, I agree with you.
And rearrange at least show some hint or whatever, because if I'm looking at it like, now what am I supposed to do then? So and once the form is inserted again, you need to be able to figure out which data field relates to which column in the data, you know, because it's hard to tell, especially if they're.
Well, but we deleted
I mean, if
the
it's,
labels
yeah, if
ourselves. We could have left the labels, right?
Mm-hmm.
It would probably make sense to provide an additional tooltip when we do delete it, so that when you hover over, you'll see what it is. Yeah.
Yeah, that'll be useful. Yeah.
Can you edit the labels in the form?
Yes, you can. Or maybe you can't at the moment. Yeah, so the editor is a work in progress. It can do, so currently you can position all the fields, but yeah, labels are not easily editable. You can do it using the textual representation, but not in the editor. But it's coming. What's also coming is the ability to provide different widgets. Well, right now I've just added the files widget that just demonstrates the flexibility of the approach. And things like, for instance, buttons and other control elements, or which could be linked to an action. So for instance, for the button, you can define what happens when you click on it. So you would be able to do simple things like order a compound or run some job, trigger some pipeline, so things like that. Inside the script, this is a JavaScript, and that it has access to the corresponding row. So using this approach, it's possible to provide build simple applications.
Andrew, so these forms, are they, the intention is that they will be for a single compound, or can they be collections of compounds displayed as well?
This particular form is for a single row. So if you have compounds in rows, yeah, it would be for a row. We do, however, have other visualizations that let you visualize multiple compounds. Let me see if I remember how it's called.
And is there a way to share the forms across users, or save them for a project?
Yes, with some limitations at the moment. So currently, you can simply download it, and at least you can reuse the file as a form and load it as you want. But also there is a way to, so for instance, if I create this form, let's say this is my form, you can always save the layout for for this view, and you can share it with other people, and it can be used for dynamic dashboards as well, so that when you load similarly structured data, you can apply, well, I didn't get the previous layout, so you can apply the previously saved layout. So this feature is also there.
So where how do you find the layouts? So you've saved a bunch of layouts. Where do they reside?
We have the gallery. They reside on a server. The trick here that we try to use is that we only show the layouts that are applicable to a particular data set you are currently have opened. So probably we need to improve the layout management a little bit. So if I open a file of a different structure, my favorite demographics data set, see, we have tons of layouts applicable to it, and you can switch between them with one click.
So who actually owns the layouts? Is it say if there's a layout that I've shared and a bunch of people have used it, and then I without me knowing that, and then I simply think, oh, that's the layout I no longer need, and I delete it. What happens to all the other users who've used it?
Good question. I don't have an immediate answer for that.
Or if I start changing the layout, will all the users with whom it's been shared gonna be affected? I can say change it in a way that will become incompatible with other people's data sets.
No, it won't affect it yet. Now I remember. So these layouts, well, you can think of them as files that reside somewhere. When you apply it, this layout gets applied to this view. At this point of time, it's no longer linked to the original layout. So now I can delete it, and nothing is going to happen to it. It's already been applied. So if you delete your layout, it will simply disappear from the gallery of layouts, which is what should be happening anyway.
Okay, and if you apply the layout and then made your data set incompatible with it by editing the table, underlying table, what's going to happen then?
Tima, you always ask the tricky questions. So nothing. Okay, so your question is if you change your layout.
Not the layout. If you change the data, the data table, for instance, you delete some columns that are used in that layout.
Oh, I see. Then the layout will not get offered. So let's do this exercise right now. We see this layout that is on top of the first one that gets offered. It has the height and weight columns that are used in this layout. Let's open the same, actually, absolutely.
No, I mean, if in this table, while it's already been applied, if you change the table.
Oh, well, nothing is going to happen. At this point, once you apply the layout, it is disconnected from the source. It's
no, I mean, if you just delete the weight column now, what's going to happen?
Yeah, scatter plot jumps to the next one. And if I delete height, yeah. At this point, it has nothing to do with the layout. That's just how all the interactive viewers behave.
Okay.
And if you modify your table, and then you look for layout, see now a completely different, well, actually a subset of previously shown layouts is shown because we've deleted the height column. So the layouts that used that height column is no longer shown.
So the mapping is done by column names, right?
Column names and column types. We also have a more elaborate way of mapping it. Our customer uses it this way, using GUIDs and some additional identifiers. So it's possible to set it up in a really flexible way. All right, so now back to forms and minor improvements. I'll mention one last improvement, but I think it's an important one. We have a pretty powerful toolbox, tooltip, apologies, in Datagrok, that by default in a grid, it shows you the values of the columns that are not visible on the screen. So it's a white table. You see, now we see the structure because it's not on the screen. And now we see the rest of the columns that are on the right. So it's pretty smart and tries to do what is best by default. Additionally, there are multiple ways to customize it. You can set the default tooltip for the whole table that all viewers will inherit. And it could be either a form or a number of selected columns. But that was an old feature. What we have new in our last release is the ability to set custom tooltips per column. So for instance, if I want to visualize custom tooltip for the molecule column, I would go to tooltip, current column, and for instance, I want to select the form. And I'm really interested, say, in the molecule ID. So I will do that. Yeah, now when I hover over it, I see that specific tooltip. Sometimes you don't need a tooltip for a column. It's also possible now. You just show nothing. Oftentimes, if you simply want to visualize a number of columns without drawing a form, you can do it like that. Just select a bunch of columns, and now it shows a fixed collection of columns, which is quite useful in cases when one column contains some sort of summarization of others. For instance, the summarization of toxicity. And when you would hover over it, you would see all the detailed risk associated with that compound. So just a nice little feature, one of the bunch that we've recently implemented. Okay, that's pretty much what we wanted to describe today. Are there any questions related either to the grid forms or overall? We'll be happy to help with anything. Okay. Our next meeting will happen in around 3 months. It might conflict with the BioIT world, so we might need to shift it by a week or two. What we will be talking about is our capability for curve fitting, then the modeling environment that we've built that is actively used by one of our biggest clients. Then the ability to solve interactively differential equations. That might sound strange, but the way it fits into Datagrok, but you'd be surprised how relevant it is. And our additional features and improvements in the area of macromolecules. So I hope to see you in about 3 months. We'll send an additional announcement. Meanwhile, thanks again for coming and have a great day.
All right, thank you. Differential equations sounds interesting. Interactively solving. Okay, I guess we'll find out what that means.
Yeah, you'll be surprised, Dima.